The overall goal of this method is to measure the chloride threshold value, which is an essential parameter characterizing the ability of reinforced concrete to withstand corrosion. This parameter is needed in all current models to predict chloride-induced corrosion in concrete.
While it is well known that chloride threshold values depend strongly on factors such as materials used, it is common practice to rely on general values stipulated in standards or textbooks. The main advantage of our method is that it permits testing of civil engineering structures. This is similar to the well-established methods for testing mechanical properties, such as concrete strength.
By testing samples from structures, we ensure real conditions which greatly influence the chloride threshold values. As an example, the steel-concrete interface, which cannot be representatively mimicked in laboratory-produced samples.
Begin by selecting test areas in the concrete structure as described in the text protocol. Locate the reinforcing steel bars in the concrete by means of a non-destructive handheld scanning device commonly known as a reinforcing steel detector. Move the steel detector both in horizontal and vertical directions over the concrete surface within the test area. Using chalk, mark each reinforcing steel bar temporarily in a grid shape on the concrete surface. Select locations for core drilling of cores with a diameter of at least 150 mm. Mark and label them on the concrete surface. Drill the concrete cores containing the segment of reinforcing steel according to common procedures and standards. After drilling, remove the concrete core from the structure, for instance, using a chisel. Finally, wrap the core